Hi, I'm George Woodbury from College of the Sequoias in Visalia, California. In this video, we're going to work with the future value of an annuity, which is an application problem of a geometric series, although it may not look like it yet. We're told that a person deposits $1,200 in an account at the end of each year for 8 years. So at the end of this year, $1,200 goes in. It's going to earn some interest during the next year and will be followed by another $1,200 deposit. Those two deposits will earn interest in the third year, and then another deposit is made, and so on and so on. The account pays 6% annual interest, compounded annually, so only one time per year, and we want to find the future value. What is this account going to have as its balance at the end of 8 years? So to see why this is a geometric series problem, the first year's deposit, $1,200, will earn 6% interest in years 2 through 8. So it's earning interest for 7 years, and it's compounded. 6% interest means that we'll take 6% of that amount and add it to the original. That's the same as multiplying by 1.06 raised to the 7th power for the 7 different years. The deposit at the end of the second year earns interest for 6 of those years. And so on until the last 2 deposits earn interest for the last year and no interest at all for the last one. So rewriting this in the other order, we can see that we've got 1,200 plus 1,200 times 1.06 to the first, plus 1,200 times 1.06 to the second, and so on. This is a geometric series where R, what we're multiplying by, is 1.06. And the first term is A sub 1, $1,200. So if we want to find the sum of this after 8 years, we'll use the formula S sub n, or S sub n equals A sub 1 times 1 minus R to the n power over 1 minus R. And here, that's going to be S sub 8 equals 1,200 times 1 minus 1.06 to the 8th power divided by 1 minus 1.06. Now we can go to the calculator to come up with this sum. We've got a fraction. In the numerator, we've got A1, 1,200, times, in parentheses, 1 minus 1.06 raised to the 8th power. In the denominator, we just have 1 minus 1.06. And there is our result, $11,876.96 rounded to the nearest cent. Now, no matter how many years we're talking about, we've got a formula for working this now. If we want to know what there would be after 20 years, we just replace the 8 in that formula by 20 and recalculate. What I want you to think about, and I'm not going to talk about, is what would be different if the money was put in at the beginning of the year. So the $1,200 goes in the first day of this year. It earns interest that entire first year. And so each of the 8 deposits would be earning interest where that wasn't really the case. So think about what you would have to change and how you would find that sum. And if you want to run it by me, reach out and let me know what you think you would do. I'd be happy to comment on that. Just leave a comment on this video, how you did it, what you got, and I'll be looking forward to that. Thanks for being with me for all of these videos. This is the last one in our algebra class. I may supplement this in the future as we go. But that's it for now. Have a great, I wish you nothing but the best in your algebra class and on your exams. And if you have any questions, you know how to reach out to me. Take care, everybody.